Light is electromagnetic radiation, right? Okay, so the thing about light is it has this thing called the reverse square law, just like all electromagnetic radiation or a radio signal. So basically, it works like this. In real life, as you drive further and further away from the city, the radio stations begin to fade because of the reverse square law. Nobody's going to argue that with me. How do we see light from 13.8 light years away if there is the reverse square law?
Oh, okay. Are you listening?
Please forgive me.
Are you listening?
Yeah, loud and clear. Yeah, I'll go on mute.
Like I say, you've got to look at a radio station which has a transmitter, which is probably kicking out a couple of kilowatts, something like that. Of course, it transmits over a certain area. You're comparing that to a star. A star, I mean, I know the flat earthers are going to say, well, we don't know what the stars are. Well, a typical star, something like Tau Ceti.
Actually, I know exactly what you guys think the stars are. Can you please continue?
Okay, a typical star similar to the sun that we have is something like Tau Ceti, a mid-range star. If you actually do the calculations, I mean, yes, you've got to assume that the sun is 93 million miles away. Yes, you've got to assume that the sun is 93 million miles away. Yes, you've got to assume. Yes, you've got to assume. Simply just doing the maths and working out the energy density of the radiation falling on Earth per square meter. From that, you can do a calculation to work out how many photons that star is kicking out per second.